Okay. Make sure I have the right one here. I do. Okay. Would everybody please, there is a small typo on here. This bottom one here is supposed to be not supposed to be there. It's not on your sheet? Oh, good, because it's not supposed to be there. You only have A, B, and C? Lovely. So I'm going to do this and just liquid paper over that, kind of. There we go. All right, everyone is good? This is what you guys are seeing, yes? All right, let's do some math. We have to do a couple of things before we go forward with this. I want to remind you of a couple of things over in this empty space over here. What does this mean in math class? Pardon? No, that's if it was a comma. It's a ratio. 2 to 3. That means there is 2 of something for every 3 of something else. Right? You all know that. That's like grade 3, right? Your teacher did the same ratio every teacher since the beginning of time has ever done. She counted all the kids in the room and did boys to girls. Right? Every one of you have done that. Right? There's a million ratios we could do in here. We could do adults to children, 1 to 29. We could do children to adults, 29 to 1. We could do stunningly gorgeous people, 1, to just regular gorgeous people, 29. Everybody with me? Everybody can make a ratio, yes? Now, hopefully, you guys are smart enough and your teacher explained that that is also what Adam said. No, not what Adam said. Adam said it was coordinates. Somebody said it. What else? How else do we write those? Fractions. Thank you. Somebody said it. I thought they did. We also write that as 2/3. Why? Because that is comparing 2 of the parts of this circle compared to all of the parts of this circle. We're all cool with that, yes? And what is the other way we write fractions? Decimal. Because this is 2 divided by 3, correct? So if all those are the same, and that will get us 0.67. I shouldn't have used 2/3 because that's a repeating decimal, but whatever. You know what I'm talking about. Everyone's cool with that, right? Okay. So what I would like for you guys to do now is to, you don't need a ruler, but just connect A and F and B and F. Now you guys are smart kids. That made a 90 degree, right? It's right on the grid. Now write the comparison. How far was it from B to F? 3. And how far was it from A to F? 4. Now how else can we write that? We can write it as 3/4, or we can write it as 0.75. Is everybody cool with that? It's easy peasy, right? Okay. Now I'm going to change color now to go to red. And I'm going to go with red. I want red, that thickness. Thank you. Now I'm going to go A out to G and up from C to G. What is that comparison? How far is C to G? One, 2, 3, 4, 5, 6, 7, 8, 9. Is it only 8 on yours? It's only 8? That's a mistake. Please slide it up one more. It's supposed to be 9. Yeah, it should be 9. And how far is it along the bottom? 12. So what's C to G? CGAG is 9 to 12, yes? So how do we rewrite that? 9 over 12. And what decimal is that? Again, it is 0.75. Everybody cool? We're good with that, yeah? You can see right there it's the same, yes? Because 9 over 12 is 3/4. Everyone is good? All right. Now the third one, we're going to go A all the way out to H. and then up from h. And what do you get? Remember, this line is down here, but it really should be up on the same line, right? How long is that one in green? It's 20. Everybody cool? From the A dot out to the H dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is 15 to 20, which is 15 over 20, which is, guess what again? Oh, okay. Yeah, I'm videoing this. Which is again 0.75. Is everybody cool with what we've done? I haven't explained it yet, but you all understand that the comparisons between all of these lines are the exact same, yes? Yeah? Okay. Now, if I do this, what did I just make? I made how many triangles? 3. I made ABF, correct? Right angle triangle, 3, 4, 5, right? Agreed? And then I made this big red triangle, 12, 9, and that's going to be 13, right? And then 20, 15, and that is going to be 25. Everybody cool? Right? Okay. What if this red and green line were right here and we were making one triangle? I had to make them staggered so you could see it. What is shared between all 3 triangles? They all share that ratio. So the numbers, they all share that ratio. Excellent. Now, how many triangles share that ratio? These 3. In math, if something happens 3 times, what can you guarantee? That it's going to happen again. So if I make this line go out here and this line go up here, what will that ratio be? Still be 0.75. What if I make this bottom line go all the way over to here and I make that diagonal line go up to the ceiling? It's still going to be 0.75. What if I go to Sumas and then up in the sky? 0.75. It's always going to be 0.75, right? Everybody understands that, yes? No matter how big the triangle gets. Now the next thing I'm going to ask, that's the first thing they share. What else do they share? The hypotenuse is in all of those lines, yes? It's not the same hypotenuse, but they all share a hypotenuse. What else do they share? Yep.
So that's like 3, 4, and like the bottom one would be like 5 over.
I see what you're saying. That's not what I'm going for right now. Stop looking at the numbers. Tell me physically something about these 3 triangles that is shared between all of them. They all have a right angle. Excellent. What else do they all have? What's this? This angle is between the hypotenuse and this leg in the little triangle, yes? Is that the same angle in this bigger triangle? Yeah. Is it the same angle in this biggest triangle? Yeah. Would it be the same angle in the line that goes to Sumas and the line that goes up in the sky? So let me ask you this. Does length of line affect the size of that angle? No, it does not, does it? If I draw a little tiny little triangle, will it have this same angle here? Yes. That is the basis of trigonometry. No matter what you do to the triangle size, the angles don't change. That's why things like blueprints work. We can draw a building this big and build this. Got it? Because no matter what happens, the angle will not change. But based on what we did yesterday, we can decide, we can change the sides and keep the shape the same. Right? Okay. So if everybody understands that, and honestly understands that, we're in very good shape, actually. This is called, some of you will know this. By the way, I need to ask, other than L, because I know L has anybody done trigonometry before? Good. Okay. Not many. This will be helpful. This is called the tangent ratio. Please learn that word. And this is true for all right angle triangles. Okay? No matter what, when I compare the two sides, okay, not the hypotenuse, okay, and that's what I'm going to write right here. When we compare, what is the proper name for the sides of a triangle that aren't the hypotenuse? Right. When we compare the legs, okay, every angle makes a unique ratio. So no matter what I do to this angle, if I make it bigger or smaller, these two comparisons will give me a different decimal depending on what I have. Everybody good? And that makes sense because what gives us the decimal? This length divided by this length. So if I change one of those lengths, I'm going to get a different angle, aren't I? Everybody cool? Now, if you really get it, I'm going to draw a line on here. Don't write down the line I'm about to draw. Just think about it for a second. I'm going to put a big purple line right in the middle there. Okay? Can you tell me exactly how long this line is? Exactly. No, you can't. Can you tell me exactly how tall this line is? No, you can't. But if I told you that this was X and this was Y on the purple triangle, could you tell me what X over Y would equal? What would it be in this triangle? X and Y. This purple triangle right here. I'm going to erase everything else. And I'm going to make that purple triangle. What is the only thing that didn't change? The hypotenuse changed, it's shorter. The angle didn't change. So this comparison is still going to be what? 0.75, no matter what. Does everybody understand that? Always. For this angle. What if I drew this triangle in green? Would that still be 0.75? No, why? Because this is a different angle. Does everybody understand that? Each of those ratios is unique to a specific angle. Okay? That's what you need to take away from this part of the lesson. Is everybody cool with that? Okay. Now we are going to do some calculator work. This should be at the bottom of your page, is it? Excellent. Before we go on, everybody's calculator needs some possible fine-tuning, okay? Everybody get your calculator out, turn it on, look at the screen. You have to do this now. I do not care if you don't normally. Get out your calculators and look at the screen. On the screen, you need to see, if this is my screen, somewhere on that screen you need to see a letter D. Or you need to see the word, not the word, D-E-G. If you have a regular calculator. If you have a fancy one like mine, which Brianna you have, you need to push mode and make sure the word degree is highlighted. Is it? Yes, the third line down where it says radian or degree, you need degree to be highlighted. Is it? Cool. So you can push clear. You're set. Everybody else, D or D-E-G. Is there anybody that does not have D or D-E-G right now? Does not. You have either an R or the word rad or a G and the word grad. This is what you want. This is what you don't. Is there anybody that has one of these two? This is not a complicated question. Which do you have? You have rad. So now, on your calculator somewhere, you need to find a button that has D, R, G, and it might have an arrow by it. Hit that button until it says D or DEG. Sarah, same as what I just showed Brianna. You need to push mode and make sure the word degree in the third line down is highlighted instead of the word radian. After you click yours, it's not going to say anything on the screen. You are just in this right mode. Okay, and we're about to make sure you're in the right mode. The next thing we do with the calculator will prove if your calculator is right or not. You good, Sarav? Okay, so everybody is on deg or degree now, yes? William, you're good? D. Okay, so you're good. Everybody's good? Robbie. Okay. Everyone's good now, yes? All right, now the next thing changes with your calculators. I'm going to write parts sometimes in black, sometimes in red. If you have a calculator like mine, when you push the button that says TAN, T-A-N, right now on a blank screen, if it writes the word TAN, put your hand up. Okay, you have what I will refer to from now on as a forward calculator. You punch in what you see. So if it writes the word TAN, to do this question, you are going to push the word TAN, then you are going to push 35, and you may, if you're like mine, it will show a bracket. You want to start getting in the habit of closing that bracket and then pushing equals. So all of you with a forward calculator should have a screen that shows 0.700 and a bunch more numbers. Everybody who has a forward calculator should be looking at that number on it right now. Are you?
Yes.
0.700. Okay, so you are not in the right mode. So hit mode again. Use your arrow keys here to go down and get the word degree flashing. And then push enter. And then go do the same thing again, tan 35. And get it to show 700. Does everybody have that? 0.700 207 5382. I only care about the 0.700. Bring it here. This is the worst day for this because everybody's got different calculators. It's super pain in the ass. Degree, enter. Then clear. Tan, 35, close brackets. Done. Okay. Everyone is good? If you have a forward calculator. Now, if you have a backwards calculator, all right, 0.700. I'm going to write that in red. And for the first few days, I'm going to show both. But then I'm going to expect you to know how to do it yourself. It is reversed. You need to go 35 tan. And you will not need to hit equals. It will show you 0.700. Can everybody with a backwards calculator make that work? Yes? All right, do the next two. What is the tan of 15? 0.3. Use a couple of decimals. 0.326. Oh, 0.26? Okay. Everybody good? Everybody can find it both ways, yes? All right, now stop for a second. 35 got me 0.7. 15 got me 0.26. What should 45 get me? Before you push a button, will it be bigger or smaller than 0.7? Bigger. Excellent. And what is it? 1. Is everybody cool? Everybody can do that with their calculator? All right, now listen to me. The tan button gets you the decimal for x over y. Please highlight the word decimal. It is not going to give you an angle. It gives you the ratio. Is everybody clear there? So if you are ever asked for the ratio of a triangle, it is this fraction or this fraction's decimal. Your calculator gives it to you. Is everybody good? Yeah? The tan button gives it to you. Yes? Everyone's okay? All right. Turn the page over. Now, read question 2 and tell me what is different. I'm supposed to find the angle, and I already have the decimal, right? So, you know that the tan button gets you the decimal, right? But I already have the decimal, so I must need to reverse this, yes? Look closely on your calculator. Written on your calculator, right above the tan button, is this. Right on the calculator. Tan -1. That is what gets you an angle. And you access that button by pushing second or shift, depending on the calculator, and then tan. Does everybody understand that? So in this case, we have the decimal. So to punch this in on a regular calculator, I need to push, I'm going to put S for shift because I'm lazy. Shift tan 0.75 equals. If you have a backwards calculator, you reverse it. 0.75 shift tan. And what do you get? So 36.86. So with angles, we round off because angles are similar to imperial measurement. We don't measure them in decimals. Angles are measured, believe it or not, in minutes and seconds, like time. So we're going to round that off. Now, you guys are smart kids. Where have we seen 0.75 as a ratio today? In the very first thing, yes? So if this ratio, 3/4 is 0.75, how big is this angle now? 37 degrees. Is everybody cool? Yeah? Okay. Now, do not do the next one. Do the third one. Tell me what this one is. What is C? 62, right? 68.2. So 68 degrees, right? Is everybody cool with that? And that makes sense. As the decimal gets bigger, the angle gets bigger. Cool? What's weird about B? It's a negative. Try it. What does it give you? Negative 51 degrees, correct? Does that make any amount of sense? It doesn't. Because when you guys think of angles, you think of a protractor, right? Which is 180 degrees, correct? But what lives under here? Another 180, right? If you're using a protractor, we count this way, don't we? Well, that would be positive. Where do you think we'd go for negative? Down that way. Understand? So if I went positive 51, I'd go up to about there, wouldn't I? But I'm going negative 51, so I would go down to there, correct? How many degrees in a circle? 360, but I went back 51. So this must be 309, correct? That's grade 11 math. I'm just showing it to you now to show you that you're going to see there is more to angles than half a circle. Everybody cool? And if you do the tan of 309, you will get negative 1.23 because negative 51 and 309 are the same thing. Good? This is kind of extra credit. Don't really worry about it. Is everybody okay with that? Okay, now this next thing is the most important thing today, and it requires you to understand something. For any specific angle, and I mean not the right angle, okay, it's the other two angles. For any specific angle and a right angle, the tangent ratio. As soon as you see ratio, you know it's a fraction. It is always compares the opposite side and that is divided by the adjacent side. Now, we talked yesterday about what opposite means, yes? What does opposite mean in math? Across. So it's a crappy triangle. There's a triangle, right? Here's the angle that I am working with. There I am, standing there, minding my own business. Where is opposite? The vertical one, the horizontal one, or the diagonal one? The vertical one, because that is what is across. There is my opposite. Right? Where is my adjacent? There are two lines that are beside me. One of those lines already has a fancy name. Which line is it that already has a fancy name? The hypotenuse. So it's not the hypotenuse. This is the adjacent. So I compare the two. Does everybody understand? Adjacent is never the hypotenuse. Because the hypotenuse doesn't get to have two special names. He already has one. Everybody good? All right, we are now going to do See if you really get it. Here's a triangle, yes? Everybody with me? Okay. I want you to tell me the tangent ratio of angle A. So, I'm going to do angle A in red. I want the tangent of angle A. And tangent is always opposite over adjacent. Yes? So let's put some numbers in there to make a ratio. What is opposite of A? 12, because it's across the way. Correct? So 12 goes on top. What is adjacent? 5, because that's beside it, but not the hypotenuse. That is the ratio. What is the other way I'm allowed to write that? As a decimal. What is its decimal? No. What is its decimal? 2.4. I don't want the angle L. That's all right. It's a mistake that everybody is going to continue to make. I only wanted the ratio. Now, what is it for B? Tan B. What is tan always? Opposite over adjacent. But I'm at a new spot in the triangle, aren't I? So what is opposite for B? 5. And what is adjacent to B? 12. So what is B's tan? 0.42. Is everybody good? Opposite and adjacent changes with where you are in the triangle. And that makes sense, doesn't it? Because where you move in the world changes the way you look at the world, doesn't it? Right now, I see Ken right in front of me. If I move, I'm going to be looking at a different face, right? So that makes sense. But what doesn't change? In this triangle, what's the one side that doesn't change no matter where I go? The hypotenuse is always the hypotenuse. Is everybody cool with this? We're going to do some work with it. If you're a little overwhelmed right now, you don't need to worry. Okay? Now, just let me make sure here. Good. You guys should have some blank space now, yes? No? What the heck? Let me see your book. Never mind, I have your book right here. What have I done here? Yeah. Oh, okay. Yeah. All right. So this is what L was doing. How do you find the angle now? So this was A, so B is find the angle. Find angle A. You have the decimal, so what do I have to use to find angles? Tan or shift tan? Shift tan. So for angle A, I need to do shift tan 2.4 or 2.4 shift tan. What do you get? Now L. 67. Do we do decimals in degrees? 67 degrees. And what is B? Equals what? 23. I know what it is. Yes. Yes. Now, the next thing I need you guys to be aware of is how your calculator works. That's why it says, what did you have to type to your calculator? I'm not going to write anything there because my calculator might be different than yours. Please write what you did. Okay? Now, remember, 2.4, you could have left it as 12 over 5. And you could have left this as 5 over 12. Which means you could have done tan, shift tan bracket 12 divided by 5. And over here you could have done shift tan bracket 5 divided by 12. And then if you were a reverse calculator, of course, you would do that in the opposite order, right? You would do bracket 12 divided by 5, close brackets, shift tan. And over here, you would do bracket 5 divided by 12, bracket, shift tan. Can everybody find angles and decimals? You need to stop me now if you can. You can't be shy. You can't in 5 minutes say, oh, Mr. Mars, I totally don't get it. You need to stop me now. If you stop me in 5 minutes, I'm angry. If you stop me now, I'm like, cool, let's fix it. Because I'm giving you a chance right now. Can everybody find these decimals, these fractions, and these angles? Yes or no? Yes? Okay. So now you guys have number 4 there, right? Okay. I'm going to do something a little weird here that's going to freak some of you out. I'm going to show you a new symbol. Just write it somewhere on the page. That symbol, it's a circle with a line through the middle of it. It's a Greek letter, theta. It just means an angle. Okay? It's an angle that we're going to work with. They use a Greek letter for it because the Greek mathematicians invented this stuff. All right? Everybody cool? They didn't really invent this stuff. Like 5 cultures invented this stuff at the same time. But we choose to use the Greeks. Everybody with me? All right. So we are going to look at just this first question. Find the missing length or angle. Missing length is tan. Missing angle is shift tan. Cool? So what do I need in A? An angle or a side? Angle. So I'm going to be shift tan, yes? I'm going to show you what you need to do for every single trig question you ever have. If you do what I'm about to do every time, you will never get a trig question wrong, ever. You cannot get the trig question wrong if you do what I'm about to do every time. Most of you won't, so most of you will not get 100%. But I am telling you, you should if you do what I'm about to do. Okay? Is there a theta? Is there an angle that I am working with? Yes. Do I know what that angle is, Tanisha? It is x. Cool? Okay. Is there an opposite value to x? What is opposite of x? 23. How did you know it was 23, Brianna? Because it was across the triangle. Is there an adjacent? It is 15. How did you know it was 15? It's not the hypotenuse. Excellent. Is this complicated? No. So now, what do I know? I know that tan, shift tan of x equals what? Opposite over adjacent, right? So now fill it in. What was opposite? 23. What was adjacent? 15. How do I do that on my calculator? Depends on your calculator. Mine, I go shift, tan, bracket. Now what do I punch in? 23 divided by 15. Close brackets equals. If you have a backwards calculator, what do you push? Bracket. 23 divided by 15, bracket, shift, tan. And you may or may not need to push equals. So what is the answer there? I got to check. because I don't know it off by heart. Who would like to tell me an answer here? 57 degrees. Is everybody cool? Okay, this is what you do. If you do this every single time, you cannot get a trig question wrong. It's impossible. Let's go to the next one. I'm going to change color to blue. Do I have a theta? An angle with which I am going to work. What is it? 15. What else do I know? Do I have an opposite? No. So what do I put there? X, because I don't have a number there. Because I went across and I see nothing. What is A? 37. Right? Is everybody cool with setting it up? Now we follow the rule. Do I need a side or an angle? Side. So am I using tan or shift tan? Just tan. Tan theta always equals opposite over adjacent, correct? Well, what's theta? Tan of 15 equals opposite x over adjacent, 37. Now we got to do algebra. What gets rid of divided by 37? Multiply. So I got to do 37 times tan 15. And I get my answer. You got to do your backwards calculate. You got to know how to work your machine. Everybody try that. Tell me what the answer. Don't say the answer out loud until I have a chance to decide on who I would like to ask. Everybody try it. 1 decimal place is all I want. There's a reason I'm doing this way. I would prefer a backwards calculator person to give me the answer right now, whatever their calculator is showing them. Who has a backwards calculator? Tanisha, what does your calculator show you right now? 86. Yes, not because you set it up wrong, because something you did wrong on your calculator. Please understand the difference. Okay? Brianna, what do you have? It is 9.9. Okay, now Tanisha, you need to do this in reverse. So work with me here. Clear your calculator off. 15 tan times 37 equals. Okay? Everybody cool? Everyone was able to make that work? All right. Let's go over to this last one, which I will work in red. Yes, Adam? Oh, do you have a backwards calculator?
No.
You have a forwards calculator.
Yeah, but when I put in 10 as a bracket instead of it?
So close the bracket.
Yeah, but then I gotta see that here.
30. Clear your... No, just sit. Clear your calculator.
Yeah.
Push 37.
Yeah.
Push times. Push tan.
Yeah.
Push 35. Wait, 15. Close brackets. Push equals. Okay? Please understand, you guys, this math is not hard. Working your calculator is hard. That is why we are practicing it so much. The calculator is doing the work here, isn't it? It's the one giving you your decimals and doing everything. All you got to do is learn how to make it work. All right, look at the next one, which I'm going to work in red. Do I have a theta? What is it? What is 14? Opposite equals 14, and my adjacent equals x. Set it up. Tan theta, which is what? 70 equals O, 14 over A, x. You guys are smart kids. When the number was on the bottom, we multiplied. So now we're going to divide. X equals 14 divided by tan 70. Punch that into your calculator. It's hard to do. Somebody is going to screw this up. You're going to write it out right, but you're not going to get the right answer. Some of you won't. I'm going to tell you how to fix it in a minute. Who has a number for me? What do you got? 5.09, which would be 5.1, right? What do you got? 5.1. What do you got? Wait! Don't touch your calculator. Push the equals button right now. It's because you cleared it off. Okay, you got a backwards calculator, right, Kirsten? So, 14 divided by 70 tan equals. Okay, your calculator's not in the right mode. Is there a D showing on the screen? So now, what? Okay, you have a forwards calculator, I thought. So 14 divided by tan 70 equals for you, Emma.
I got 5.09.
Yes, that's right. Because 5.09 rounds off to 5.1. So Emma, 14 divided by tan. Excellent. Kirsten, 14. You got it now? 14 divided by 70 tan equals. Bring me your calculator. It isn't, or you're not punching in what I'm telling you to punch in. 14 divided by 70 tan equals. I'm not magic.
Well, you said that you didn't press the whole button before.
Do I need to rewind the video and show me saying to you to push equals twice? I know. Is everybody good? Can you do this? All right. Let's actually apply it to a situation. Here is a triangle with more than one piece of missing information. Is it a trig question? Yes, because we're in the trig section. What should you do with every trig question? Write it out. Do I have a theta? An angle with which I am working. What is it? 30. What do I know about 30? Do I have an opposite? X. Do I have an adjacent? 24. Can I do something mathy with that? Yes or no? Sure I can. Tan of what? 30 equals opposite over adjacent. So what? X over 24, correct? Everyone agree? How am I going to solve that? Numbers on the bottom, so what math is it? Times. So 24 tan 30 will give me X, correct? Everybody do that, and do not clear your calculator. Just do the work. It depends. Some calculators you need to, Brianna. Yours you don't. So I like to tell everybody to put the times in until they start recognizing that they don't. But some calculators you need it, some you don't. But it won't give you the wrong answer if you do it, even if you don't need to. Sarav, what do you have? Absolutely right. So 13.9, correct? All right. So we are going to write 13.9, but we're not going to clear our calculator. So here is what your calculator should be showing you. 24 tan 30, close brackets, equals. Everyone should be looking at that number, yes? Now, is there another piece of information missing from this triangle? What is it? No, we have the adjacent. The hypotenuse. No, you just got the opposite. You found what x was, right? So we just need the hypotenuse, yeah? What do you do to find a hypotenuse? Pythagoras, of course. So you are already looking at this, right? So I know that y equals the square root of x squared plus 24 squared, yes? But you know x is 13.9. It's sitting on your calculator, isn't it? So all I have to do is, there's my number. I hit the squared button, the x squared button. I add 24 squared, and I get an answer. What is the last step in Pythagoras? So it equals the square root of 768 which is whatever it is. You use your calculator to find that. 27.7. Can everybody do this? That's trig. If you can do this, there's two other things you have to learn, but they follow the same rules. If you understand these rules, you actually understand everything you need to know. You know those dudes that go out on the street and look through a telescope at another dude with a laser, and they're wearing a high-vis vests, and they're getting paid tons and tons of money? They're doing grade 10 trig for a job. It's called surveying. If you can look through a telescope and you can do grade 10 trig, you can make a living. It's pretty easy. Is everybody good? All right, let's try these three. I want you to try them one at a time, and I'm not going to show you how to do them. Oops. So you go ahead and try them. I'm going to write down my right answers, but I'm going to blank out the screen. Where's my button? Ba-ba! The answers are 35 degrees, 12.1, and 1.8. Was everybody able to do trig? Yes? Yes? Okay, remember, the hardest thing is making your calculator do what you want it to do. Because the algebra is easy, right? Oh, I get rid of a denominator by multiplying. Okay, no problem. I get rid of a numerator or a denominator by dividing. No problem. Right? Easy peasy. It's making your calculator do the right thing that's hard. Now I want to show you one more thing before I let you loose. And you're about to move into your blue workbook. You're going to do the very first page in that blue workbook. Okay, you don't need to write down what I'm about to write down. I'm going to do it again later for you. But I just want to show you something. If I were standing right here, on the ground, and this hypotenuse isn't there, how would I get myself to there? What would I have to do? I would have to walk along here and go up, wouldn't I? Everyone agree? And once I'm up there, I could look back at where I started and draw this line, yes? That makes this the angle of inclination. Because I had to go up to get to it. So when you do the first couple of questions, it's going to talk about the angle of inclination. The second question actually explains what it is. Then I'm going to do some more work with this later, but for now, that's all you need to know. If you go up, you make an angle of inclination. So it is this angle in here for which you are looking. Cool? So you are going to do in your blue book, the very first page of your blue book, which is labeled as page 76. Even though it's not, it's page 1. Okay? Because it came out of an old textbook that I don't like to use anymore, and I don't want you guys to have to carry it home. But I already had an outline that had page 76 on it, right here. Okay? All right? So you just do that page. That's your homework for tonight. Just that page. Now, if you look at it, you will notice the answers are right on there for you, yes? So you can check your own work. Cool? Okay, that's your job. Page 76 is what it is labeled as, but it's the first page in your blue book. Are you allowed to work right in your blue book? I don't care. If you can cram the work in there, go ahead and do so. If you want to work on your own paper, go ahead and do so. I don't care. All right? Work together. It is not a test.